As a land-grant institution, part of the UF IFAS mission is conducting research, a process that often takes a lot of time. A new technology at UF IFAS Research, the PlantArray, is helping to accelerate field trial time requirements, bringing impacts to growers and consumers faster.
This is something that makes UF the perfect place for the PlantArray. The data that comes off of a single pot in a single experiment, even if we only run it for like a week, is just absolutely massive.
This futuristic phenotyping platform can measure plant growth and stress under different environmental conditions. The fully automated system uses sensors to accurately assess plant responses to both soil and air conditions. Developed in Israel, the PlantArray allows researchers to easily perform a variety of tests in about half the time of a field trial. Each pot has a microcontroller or mini-computer attached, and information is sent to a centralized computer that documents plant changes. Measurements examined include the plant's weight, growth rates, water loss, and water use efficiency. Director of the UF PlantArray, Dr. William Hammond, says this system will help reduce the time needed to find which plants will be best suited to both grow and survive under future climatic conditions.
When you can get data coming off of each one of these computerized digital pots every 3 minutes, we can get insights in near real time into how the plants are using the water, how rapidly the plants are gaining carbon from Earth's atmosphere, and this can help us make some decisions about maybe which particular plants are going to perform best or worst without having to wait that plant's entire life cycle, or without having to do an entire multiple months long field trial.
The PlantArray is made up of fully independent modules that provide enormous flexibility to adjust experimental designs to the needs of each user. Each configuration can be vastly different from others. Cepheus says the PlantArray can revolutionize the way research is done and attract grants to further expand the system and its research capabilities.
I see a lot of potential for improving our ability to assess plant performance, both in terms of production as well as climate resilience.
Climate resilience is an important area of research for the future of plants, the planet, and people. All plants have traits that make them resilient or vulnerable to stress, attributes that demonstrate which plants might survive climate changes such as droughts or heat waves. PlantArray experiments can mimic stressful environments, and the data can be used to unveil the characteristics that will make plants more resilient to such stressors.
We're really excited to have the PlantArray as a resource that we can use in these projects, which allow us to kind of take the lead in helping improve the climate resilience of the plants that are being grown agriculturally here in Florida.
The PlantArray's impact could be felt beyond the state of Florida thanks to Hammond's and Cepheus's mechanistic approach to research. Mechanism-based PlantArray experiments could quickly identify candidate species and varieties from all over the country that are likely to succeed in field tests.
We're still going to need to, after screening on the array, do field trials. We're going to need to put plants in high replication out in various soil types and in different fields and validate that some of the insights coming off of the array are bearing production and sometimes literal fruit in the field. But it's got a lot of promise, and I think it can really help us kind of accelerate that process of getting to the stage where we're trying to test things out and make actual recommendations. And there are a lot of faculty here at UF that work on that more applied side, and we're really excited to use this facility to kind of like accelerate that alongside and in collaboration with them.